Hello. Line inclined to only one of the two reference planes, the HP and the VP. In this lecture, we are going to solve problems on lines inclined to only one of the two reference planes. So this is very important. You should remember when you solve problems on lines. If a line is parallel to VP, then front view gives true length, front view gives true inclination with HP, and top view parallel to XY line. And if line is parallel to HP, then top view gives true length, top view gives true inclination with VP, and front view parallel to XY line. Of course, top view gives details with respect to VP. So if line is a parallel to VP, then its top view must be parallel to XY line. Front view gives detail with respect to HP. If line is parallel to HP, then front view must be parallel to XY line. Also here, remember, true length is always associated with true inclination. True length always gives true inclination. Not only that, if front view is true length, then top view is parallel to XY line. And if top view is true length, then front view is parallel to XY line. This information is very important when you solve problems, not just on the lines, but you solve problems on solid sections of solids or projections of planes, etc. So read the problem. Line AB 70 mm long is inclined to HP by 45 degrees and it is parallel to the VP. Its end A is 15 mm above HP and 20 mm in front of VP. Draw projections of the line if its end B is in the first quadrant. By the time you read last statement of the problem, you have forgotten the information that was given in first statement of the problem. So remember now what I am telling you. Read problem only once. But each and every statement in the problem suggests you something. Bring that information on paper using standard notations. What I mean by this, you will understand. Line AB 70 mm long. So this is a true length of the line. This is the notation we use for true length of a line. It is inclined to HP by 45 degrees. Now what notation we use for inclination with HP? Inclination of line with HP. Theta. So theta is given 45 degrees. And it is parallel to VP. So line is parallel to VP. Now when you read this statement that line is parallel to VP, immediately what you should realize that line is parallel to VP means its front view gives true length and true inclination and top view is parallel to XY line. So we have this information now. Front view gives true length, front view has true inclination theta and top view parallel to XY line. What else? Its end is 15 mm above HP and 20 mm in front of VP. So here right now we are just noting down the data. So this line is say XY line and this is the projector. Projector of point A. So two views of a point lie on same projector. So we are going to mark A and A dash on one single vertical line. A is 15 mm above HP, so 15 mm above XY line and front view gives distance from HP. 20 mm in front of VP, so 20 mm in front of XY line and that is top view of point A. When position of a line is given in a problem, remember what I am telling you. Out of infinite points on the line, you will be knowing position of at least one point on the line. Here it is position of point A, end A of the line is known to you with respect to HP and VP. That point is a reference point. Here point A is a reference point. Draw projections of the line if its end B is in first quadrant. End B is in first quadrant. What do you mean by that? B dash, that is front view of point B, is above XY line and top view of point B is below XY line. So let's note down that information also here. Front view above XY line and top view of point B below XY line. B dash and B, their position is right now unknown. It is in first quadrant, that's all you know. But where exactly with respect to HP, VP, we don't know. Distances, we don't know. So that is why I have made this circle. Means confirm position of B dash or point B, we don't know yet. Okay, let's proceed. So roller, set roller with horizontal edge of paper, roll it downwards and draw XY line. Immediately label XY line, that's important. Now draw projector of the reference point. Here reference point is A. So mark front view and top view of the reference point. So measure these distances very carefully. It's given. Point A is 15 above HP. So 15 above XY line I have marked A dash. And 20 in front of VP. So I have marked point A. Now set roller with XY line and draw horizontal lines through A dash and A. This is what you are going to do always. Always in all problems on projections of lines. As I told you, you will be always knowing position of at least one point on the line, and that point is a reference point. Once you mark front view and top view of the reference point, draw horizontal lines through the reference point. Okay. And now we are ready to draw front view. Line is AB. So how you label its front view on drawing paper? A dash B dash. So A dash is already here. Now A dash B dash is front view, and we know that front view has true length, that means 70 millimeters, and front view has true angle, that is 45 degrees. So simply at point A dash you draw line at 45 degrees and of length 70 millimeters. So set protractor here at point A dash, not at A, because we are drawing front view, means we are drawing A dash B dash. So at A dash, measure that angle 45 degrees and draw the line at 45 degrees. And this line has true length, means 70 millimeter, because front view is true length. So B dash. So this is how we have labeled B dash. Remember, when you measure this angle 45 degrees, position of the other end, in which quadrant the other end is, that matters. It's very important. In this case, point B is in first quadrant. So B dash we want above XY line. That is why we have measured 45 degrees angle upwards. Now don't forget, two views of a point lie on same projector, and that is why through B dash you should draw a projector and tell yourself that on this vertical line point B is. So on this vertical line point B is. So is this point of intersection point B, or is this point of intersection is point B? So you are not at all confused in that, because you already know that in this problem top view is parallel to XY line. So top view is parallel to XY line, means AB is parallel to XY line. So that means here it is point B. Point B is on this vertical line because two views of a point lie on the same projector, and we also know that AB is horizontal, so certainly this point is point B. So I have labeled that point as B and make top view dark, and length of top view is not true length here. Insert all dimensions in the drawing after completing the drawing. So let's insert. Now all in the sense, all those dimensions which are given in the question, or all those dimensions which you have used in construction of the drawing, you should insert in the drawing. But don't unnecessarily insert extra dimensions. 15 millimeters, 20 millimeters, check here, these are the dimensions given. 45 degrees this angle, and that true length 70 millimeter we should write nearby the diagram. So only these four dimensions given, check here, or we used in the drawing: 70 millimeters, 45 degrees, 15 millimeters and 25 millimeters, and these four dimensions are there in the drawing. Now this information is not required in the drawing because that all is available in the drawing itself. So finally this is how your drawing will appear on drawing paper. This is how your drawing will appear on your drawing paper. Now read the problem. Line AB 70 millimeter long, so true length is 70, inclined to HP by 45 degrees. inclination with HP means theta. Theta is 45 degrees. And it is parallel to VP. Line is parallel to VP. What does that mean? Its front view is true length, front view gives true angle with HP, and top view parallel to XY line. Its end A is 15 above HP and 20 in front of VP. So end A is 15 above HP, means above XY line. Front view gives distance from HP, and 20 in front of VP. So top view in front of VP. Point B is in fourth quadrant. It means B dash and B, both views of point B must be below XY line. So when you measure this angle theta 45 degrees, you will have to take care of this, that end B in fourth quadrant. Do you remember in the last problem, end B was in first quadrant. Yet position of B dash and B is not known. That is why I made the circle around that. That reminds us that B dash and B are below XY line, but exact distances are unknown. Now set roller with horizontal edge, roll it downwards, label that line as XY line, then projector of the reference point. Here reference point is again A, measure 15 millimeter A dash and 20 millimeters A. Then set roller with XY line, draw horizontal line through A dash, draw horizontal line through A. And we can draw front view because length of front view is true length, which is known. And inclination of front view is true inclination with HP, and that is also known. Means A dash B dash. A dash B dash is front view. So we can draw now A dash B dash. What is angle of A dash B dash? 45 degrees. So let's measure it. But wait, we are measuring this angle in downward direction. This way. In the last problem, if you remember, we had measured 45 degrees upwards, and here it is downwards. Why? Because we want B dash below XY line. So this is how we got B dash below XY line. This length A dash B dash is front view 70 millimeter long and at 45 degrees. So this is the front view. You should make it dark. Now vertical line through B dash. Now vertical line through B dash. What do you mean by that? Projector of B dash. Vertical line through B dash, on the same line there must be point B. That is why once you have labeled a point, front view or top view, whatever, once you have labeled a point, you should draw vertical line through that point for the other view of the same point. So we'll draw vertical line through B dash for B, and here it is B. So unnecessarily don't extend this line up to top of the page, because we are sure that AB is horizontal, top view is parallel to XY line. So on horizontal line through A, point B is. So that is PL. Make it dark because it is top view. So there are so many lines in the drawing, but only that front view A dash B dash and top view AB must be dark. Listen, only AB, that is top view of the given line, and A dash B dash, front view of the given line, only these two lines must be dark or thick in your drawing. All other lines must be faint lines or thin lines, because all other lines are construction lines here. And now we'll insert dimensions. So given dimensions only, so 15, 20, then angle 45 degrees, and true length 70, that you write nearby the diagram. And finally, this is how the drawing will appear in your drawing. Now also take care, TL, that is this length, true length. PL, when you label a line, that label must be above the line. So check here, TL is written above the line, not below the line. PL is labeled above this line AB, not below the line. Also dimensions are inserted above the dimension line and along the dimension line. So 20, don't write 20 below this dimension line, above. That means dimension line should appear as if it is underlined. Dimensioning is very important in engineering drawing. Now read this problem. Line PQ 80 mm long is inclined to VP by 50 degrees. So true length is 80. And it is inclination with VP, inclination of the line with VP. What notation we use for that? Phi. Remember, theta inclination with HP and phi inclination of line with VP. A line is parallel to HP. What does that mean? It means top view is true length. Top view gives true inclination and front view parallel to XY line, because front view gives details with respect to HP. So if line is parallel to HP, then front view should be parallel to XY line. So we know this information. Then which is the reference point? Let's check. Its end P is 20 mm and 40 mm from HP and VP respectively. So HP with HP and VP respectively. We don't know whether it is above or below. Wait, let's read further. Draw projections of the line if it is in second quadrant. So line is in second quadrant. What do you mean by that? All points on the line are in second quadrant. It means its end P is in second quadrant. So both the distances of point P are to be measured upwards, above XY line. So let's mark. So 20 mm it is P dash, because front view gives distance from HP, and 40 mm that is P. P and P dash both above XY line. And line is in second quadrant. Then where is the other end, that is the end Q of the line? It is also in the second quadrant, means both views of end Q, Q and Q dash must be above XY line. Draw XY line, label it, then draw projector of the reference point. Now listen, line is in second quadrant, means both views of the line you will get above XY line. No view is below XY line, so no much space is required below XY line. So projector of this point P also I have drawn above XY line, not necessary to extend it below XY line. Okay, so measure point P and P dash 20 and 40 mm. As usual, draw horizontal lines parallel to XY line. Okay, now we know that top view gives true length and top view gives true inclination. What is true length? 80, and true inclination is 50 degrees. Top view means a PQ labeled with small letters. So we know PQ, and Q dash you want above XY line. Here it is XY line. Q dash you want above XY line, and Q also you want above XY line. So here is P. So we are drawing PQ. So at point P you will measure angle 50 degrees and draw the line of true length 80 millimeters. So this is how we have drawn top view PQ. Top view gives true length. Check here, true length 80 millimeters. So this line is 80 millimeter long at 50 degrees. Now once you get point Q, you know that Q and Q dash lie on same vertical line, and that is why through Q we are going to draw vertical line for Q dash. Not only that, we know that front view is parallel to XY line, means the P dash Q dash is horizontal. So from Q vertical line, and here it is Q dash. Join P dash Q dash with dark line. This is not true length. What is length of elevation? EL. That is what notation we use, EL. Don't measure it, it's not necessary. Okay, so we have completed the drawing. Check here, here it is XY line. Line is PQ. Its front view is a P dash Q dash and top view is PQ. Both views of the line are above XY line, means line is in the second quadrant. Okay, now all given dimensions, that is 20, 40, 80 and 50 degrees. So 50 degrees is here and true length is 80, that will write nearby the drawing. So finally, this is how the drawing will appear on paper. True length, instead of inserting inside the diagram, it is better to insert nearby the diagram but outside the diagram. Now example 4. When viewed from front, line RS appears 60 mm long and parallel to XY line. It appears 60 mm long from front, means the front view length is given. Front view length means EL. E for elevation. Elevation means front view. So front view length means elevation length, that is 60 mm. When viewed from front, also line appears parallel to XY line, means front view is parallel to XY line. Now read here, the line is inclined to VP by 55 degrees. It is not front view of the line inclined. It is not top view of the line given inclined at 55 degrees. It's given the line itself. The original line is inclined to VP by 55 degrees. So inclination of line with VP means angle phi is given. True inclination with VP, we say. It is 55 degrees. Its end R is 50 mm in front of VP and 20 mm below HP. So point R is reference point. 20 mm below HP. So front view gives distance from HP. 50 mm in front of VP. So point R is in fourth quadrant, that you will realize now. Draw projections of the line if end S is in the third quadrant. Third quadrant means top view must be above XY line and front view must be below XY line. Remember, position of the other end is important. While measuring inclination given in the problem, while measuring that inclination, we are going to take care of position of the other end. Now, front view parallel to XY line. This information in the problem that suggests you immediately that line is parallel to HP, because front view gives detail with respect to HP. So line is parallel to HP, and line is parallel to HP means top view gives true length and true inclination. How you label top view? Here it is a line RS, means top view is RS and front view is R dash S dash, labeled with small letters. Okay, so this top view RS has true length and true inclination, and front view R dash S dash is parallel to XY line, and this information is enough to continue. Okay, so here it is XY line. Draw projector of that reference point. Mark that reference point 20 and 50 millimeters. Remember, 20 millimeter is distance from HP, so R dash is at distance 20 millimeter. And top view is at distance 50 millimeter, because top view gives distance from VP. Now, as usual, draw horizontal lines through the reference point. And now top view has true length, means what? But true length is not given. Okay, then what we should do? So simple. We know that front view is parallel to XY line and front view length is EL. What do you mean by EL? Front view length. So length of front view is known, 60 millimeter, and also we know that front view is parallel to XY line. So front view means R dash S dash. So R dash S dash I have measured 60 millimeters. So EL is 60 millimeters. So we got front view. We could complete front view easily. Now top view is RS. What is length of top view? True length. True length is not given. But at least we know that top view has inclination 55 degrees. So measure that inclination 55 degrees. Now I am measuring that inclination upwards because top view is RS. So we want that RS, point S, above XY line. That's given in the problem, that top view of point S is above XY line. Refer the information. So we want S above XY line, and that is why we should measure that angle 55 degrees above the reference line. So this is the line RS, but we couldn't mark S because we don't know true length. So on this line somewhere point S is. And now from S dash draw vertical line, and we are sure that S is on this vertical line because S and S dash, front view and top view of a point, lie on single projector. So S and S dash both are on this vertical line. So here it is S dash, means on the same line point S is. So S dash and S on same vertical line. So here you will get S. We got confirmed position of point S. Now join R and S, R and S, and this is top view. And check here, top view gives true length. Now remove this labeling. It was rough labeling just to guide us that point S is on this line. Now remember, slowly you will realize that while solving problems on lines inclined to both the reference planes, you are going to draw many horizontal and vertical lines in the drawing. So sometimes we get confused on which line which point is exactly, and that is why it's better to label those lines roughly in this manner, that this particular line is the line on which S dash is, or this particular line the line on which point S is. And once you look at the correct position of that point on the line, you can remove that rough labeling. R dash S dash is front view and RS is top view. Now check here, find the true length of the line. You are asked to find true length of the line. So find in the sense, just measure this RS. Measure that length RS and you will get the true length. But what else is asked in the problem? Find the true length of the line and also find length of the portion of the line in third quadrant. Okay. One end of the line is in fourth quadrant and the other end of the line is in third quadrant. Top view above, front view below. Where top view intersects XY line. Now front view is not intersecting XY line, top view is intersecting XY line. So where top view intersect XY line, label that point as T. Any letter you can use. But what is importance of this point? Try to understand. There are infinite points on the line. On this line RS, there are infinite points. Out of those infinite points, one particular point we have labeled as T. So point T is on line RS. And this is top view of point T. Simple. RS is top view of the line. Top view of the line means top view of all points on the line. So T is one of the point on the line. So this is top view of point T. So draw vertical line through T. Matlab projector. That means projector of point T and you will get T dash. Remember R dash S dash is front view of the line. Front view of line means front views of all points on the line. So front view of point T is also here. So now what is special about this point T? Try to understand. This is the point where the line intersects VP and enters into the other quadrant. Check now portion of the line RT. RT is top view and R dash T dash is front view. Just focus on this portion of the line. RT is top view and R dash T dash is front view. Both views below XY line. What does that mean? Portion RT of the line in fourth quadrant. Now focus on this portion TS. TS, top view is above XY line and front view is below XY line. Top view above and front view below. That means this portion of the line is in third quadrant. Now what is asked? Find length of the portion of the line in third quadrant. Which portion is in the third quadrant? TS. So measure that length TS. Not here. Front view is not giving true length. Top view is giving true length here. Here top view is true length. So measure this length TS. That is the length of the portion of the line in third quadrant. Now listen. RS, that is true length of the entire line, and TS, only this portion, that is true length of the portion in third quadrant. Measure it and write the answer. So true length is 105 and length of the portion in the third quadrant is 44 millimeters. Now construct this drawing. Just refer the video, pause the video if required and complete the drawing and be sure that you get these dimensions. Now we have solved the problem. Now we should insert the dimensions. So all given dimensions 20, 50, 60. 60 we have not yet. But what is 60? It is EL. So check here. This length R dash S dash is EL and that is 60 millimeter. Remember only true length we write outside the diagram this way. But 60 millimeter it is length R dash S dash. Front view is parallel to XY line and length of front view means EL. So that is what we have inserted here. So all given dimensions we have inserted and whatever asked in the problem, that is true length of the line and length of portion of the line in third quadrant, that you write nearby the drawing properly. It is not necessary to mention unit here, because always for entire drawing sheet we write one statement here, all dimensions are in millimeter. In this lecture we solve problems on lines inclined to only one of the two reference planes. Lines inclined to both the reference planes we will study in the next lecture. Till then, bye bye. Thank you.